Hey, welcome to the Mentored Engineer. I often get the question of, hey Corey, I'm having a hard time troubleshooting my wiring diagrams. Is there a way to simplify them? And the answer is yes. But before we get onto the solution, let's talk more about the problem. And I got a quick story about how this has impacted me in a personal way. So last year, I took my kids, my two oldest girls, up to Cedar Point for a week. And we had 4 great days at the park, and then it came time to leave, and our car didn't have air conditioning. So, me liking to fix things, I stopped at the side of the road, popped the hood, and noticed that the air conditioner clutch is not working. It's not engaging at all. So I know it's an electrical issue. So, get out the manual and we start looking, okay, where's the relay? And we start troubleshooting. I had a voltmeter with me, which by design, I travel with a voltmeter. And got figured out that the coil is not coming on for that relay. So then we started looking for the next likely thing, the fuse. Not listed in the fuse manual there. Very disappointed because we rode home the entire way in the sweltering heat and it was not fun. So when I got home, I dug into it deeper and found the wiring schematic and it was fuse 6. And wouldn't you know it, fuse 6 was blown. And I replaced it, air conditioning works. Could have done it on the road, but didn't. So my girls were not too happy when they found out that they could have driven home with air conditioning had I spent about 5 more minutes trying to figure out the problem. So let's look at the problem here in detail, and we'll stick with cars here. So we have lights on a car, and theoretically you need 3 wires. You need battery positive to the light switch to the lights, and lights to the ground. Completed circuit, electrons flow. Very simple. So we do have one problem with this, and that is we're going to have to insert a relay in the circuit to handle the large current that needs to go from the switch, which is usually located on the steering column, to the lights. Lights take a lot of current to operate, and we don't want to run a thick wire into the steering column for 2 reasons. 1, it takes up a lot of space, and 2, every time you turn the steering wheel, it's going to fatigue those wires, and big wires do not bend well at all in high cycle applications. The little wires can be routed a number of different ways, so we put the relay in there, and now our wire count goes from 3 to 4. And so really you're going to have theoretically 4 wires, but probably 6 because you're going to have to run thinner gauge wires to the steering column and thicker gauge wires to the lights themselves. Gets complicated, right? Well, that's just one function, right? What if we got a dome light? What if we have a horn? And now our wiring diagram starts to look like this, and a whole bunch of wires cross, and we're going to have different gauges for different applications. So that's not even including things like your stereo, your window controls, windows going up and down, the door locks, wipers, the engine controls. There's lots of stuff that goes on here. So this can get very messy very, very fast. So Corey, what's the solution? Excellent. I like talking solutions. I don't like talking problems. So the solution here is something called ladder logic. Ladder logic gets its name from its shape. It's basically 2 rails where we have 0 volts, and then in our case 12 volts, but it can be anything, 24, 120 volts AC. So we have our 2 rails, the sides of the ladder, and then we're going to start adding in rungs. Now the rungs are going to be where the logic is, so we're going to have inputs near the high voltage and outputs near the 0 voltage. So we're going to have this, where the light switch is connected to the left rung, and then the output of that switch is going to be connected to the lights, and then the lights connected to the 0 volt rung. First wrinkle here is we got a relay in that circuit, so we actually have to divide that into 2 rungs. So any relay is basically an input side and an output side. So the output side is going to be the coil. That is what we energize to get the inputs to change. So in a typical ice cube relay like this one, we have a coil, which has the pins going the opposite way of everything else. We have our common wire, and then we have our normally open set of contacts and a normally closed set of contacts. In an automotive relay, you generally only have 1 set of contacts, so you'll have 1 normally closed, 1 normally open. So those will be represented by the symbols you see here. So when we go and add the relay into our light switch circuit, it's going to look like this, where we have two rungs. The first one operates the relay coil, and the second one is the contact from that coil operating the lights. The next thing we can do is start adding in the other ones. We got two rungs for the horn, we've got two rungs for the dome light, and you notice here that none of those wires cross, which is a big improvement from what we had before, where we just had wires connecting everything. So before I get on to my last point, please take a second to subscribe to the channel and give this video a like so that it can get out to more and more people who might find this helpful. So the last point here is the improvement in troubleshooting. So I know here that if my lights don't come on, I'm going to work my way back. Well, did the control relay come on? Well, if it didn't, that's an issue with the first rung of the ladder logic. If it did, it's an issue with the second rung, and I've dramatically reduced the number of things that I need to troubleshoot. So this is a huge improvement in helping to troubleshoot, where I don't have to trace as many wires, and I can isolate where the problem is and what could be causing it. Well, that's it for this video. We're going to have many more in this series, so please take a second to subscribe so that you can get the content that will be coming out shortly. So if this kind of thing is something that excites you, I have some templates for you in AutoCAD that you can download for free and get ahead of all your peers, because your ladder logic templates are going to look so much better than theirs. Thank you, and have a wonderful day.